The story begins with the legendary Boeing B-29 Superfortress, one of the most advanced and powerful aircraft of World War II. Designed as a high-altitude strategic bomber, it introduced groundbreaking technology such as a pressurized cabin, remote-controlled gun turrets, and an analog fire control system, features that were revolutionary for its time. With a crew of 11, including pilot, co-pilot, bombardier, navigator, and multiple gunners, the B-29 was built for complex, long-range missions. Powered by four Wright R3350 engines producing 2,200 horsepower each, it could reach a maximum speed of 357 miles per hour with a range of around 3,250 miles and a service ceiling of 31,850 feet. With over 3,900 units built between 1943 and 1946, the B-29 played a crucial role in both World War II and the Korean War, carrying out long-range missions with precision. Its development required immense engineering effort and coordination, making it a symbol of American industrial capability. The aircraft was capable of high-altitude bombing as well as low-altitude incendiary attacks, demonstrating remarkable versatility. Most notably, it became the only aircraft in history to deploy nuclear weapons in combat, marking a pivotal moment in modern warfare. Despite its immense cost, making it one of the most expensive military projects of its era, the B-29 set the standard for future bomber designs, combining advanced technology with operational reliability, and remained a key asset in service until the early 1960s. As aviation needs evolved, the Boeing KB-29 Superfortress emerged as a crucial modification of the original B-29. This variant was specifically designed for aerial refueling, a revolutionary concept that dramatically extended the operational range of military aircraft. Early systems like the looped hose method were complex and required precise coordination between multiple crew members, but they laid the foundation for future advancements in mid-air refueling. These early experiments highlighted both the technical challenges and the immense strategic potential of keeping aircraft airborne longer than ever before. Later, the KB-29P introduced the more efficient flying boom system, which became the standard method used by the United States Air Force. This innovation allowed bombers and even fighter jets to remain airborne for much longer periods, significantly enhancing mission flexibility and global reach. During the Cold War, this capability played a key role in maintaining constant readiness and long-distance strike potential. Overall, the KB-29 proved that aerial refueling was not just possible, but a game-changing necessity for modern air power, shaping the way long-range missions would be conducted in the decades to follow. Another experimental branch of development was the Boeing XB-39 Superfortress, which tested alternative engines for the B-29 platform. Instead of the original radial engines, the XB-39 was equipped with liquid-cooled Allison V3420 engines, aiming to solve potential reliability and production issues faced by the standard B-29 engines. The main goal was to ensure that aircraft production would not slow down or stop if engine shortages or technical problems occurred. While initial flight tests showed promising performance and even highlighted the potential for improved efficiency, the project faced delays and changing priorities. By the time testing progressed, the standard B-29 was already successfully deployed in combat, reducing the need for a new variant. As a result, the XB-39 never entered mass production. However, it still proved an important experiment, showcasing the flexibility of the B-29 design and the determination of engineers to explore alternative technologies during wartime. The broader category of B-29 Superfortress variants includes a fascinating array of adaptations that extended far beyond its original role as a strategic bomber. Among these were transport aircraft like the C-97 Stratojet, which used the sturdy B-29 airframe to carry cargo and troops over long distances, demonstrating the design's versatility in peacetime and military logistics. Aerial tanker versions, including the KB-29, transformed mid-air refueling from a novel concept into a reliable operational practice, greatly enhancing the range and effectiveness of subsequent bomber and fighter missions. Reconnaissance variants contributed critical intelligence, while some B-29s were even repurposed for early television broadcasting experiments, showing the aircraft's adaptability for civilian technology testing. The global impact of the platform was undeniable, as the Soviet Union reverse-engineered the B-29 to produce the Tupolev Tu-4, a near-identical heavy bomber that underscored the aircraft's technological superiority. Collectively, these variants reveal how the B-29's innovative design allowed it to evolve into multiple specialized roles, influencing aviation development worldwide and leaving a legacy that stretched far beyond its original combat missions. Transitioning into the jet age, the Boeing B-47 Stratojet represented a significant leap forward in strategic bomber design. Introduced in the early 1950s, the B-47 featured advanced swept wings and 6 powerful General Electric J-47 turbojet engines, each producing around 7,200 pounds of thrust, enabling it to fly faster and at higher altitudes than any piston-driven bomber before it. With a maximum speed of about 607 miles per hour, a combat range of 2,013 miles, and a service ceiling of 40,500 feet, it brought a new level of performance to military aviation. Its aerodynamic design was heavily influenced by German research on high-speed flight, particularly swept-wing technology, which improved both efficiency and stability at transonic speeds. The B-47 was primarily developed as a nuclear bomber during the Cold War, becoming a cornerstone of the United States' Strategic Air Command and a key element of deterrence strategy. Due to early jet engine limitations at low speeds, the aircraft used JATO, jet-assisted takeoff, rockets to help it lift off when heavily loaded, each providing additional thrust. While it never engaged in combat in its intended nuclear role, the Stratojet made important contributions to reconnaissance and intelligence missions. However, its service life also came with risks. Around 203 aircraft were lost in crashes, resulting in 464 fatalities, highlighting the challenges of early jet technology. Despite this, the B-47's speed, altitude capability, and innovative design secured its place as one of the most influential transitional aircraft in aviation history, also shaping the future of modern jet airliners. Following the B-29 lineage, the Boeing B-50 Superfortress emerged as a significant evolution, featuring more powerful engines, a strengthened airframe, and overall improved performance. Designed to address the limitations of the B-29, the B-50 acted as a transitional platform, bridging the gap between World War II-era bombers and the emerging generation of jet-powered aircraft. It incorporated advanced technologies for its time, including enhanced avionics and pressurization systems, and played a key role in extending the reach of strategic bombing through aerial refueling. The B-50 also made history with a groundbreaking non-stop flight around the world, showcasing both its range and reliability. While it did not achieve the iconic status of its predecessor, the B-50 was an essential asset during the early Cold War, supporting reconnaissance missions, nuclear deterrence strategies, and global military readiness. Remaining in service for nearly 2 decades, it exemplified the evolution of strategic bombers and set the stage for the jet age that would follow. The evolution of strategic bombers reached its pinnacle with the legendary Boeing B-52 Stratofortress, one of the longest-serving military aircraft in history. First taking to the skies in 1952, the B-52 was engineered as a nuclear-capable bomber with true intercontinental range, capable of carrying massive payloads over vast distances. Operated by a crew of 5, including pilot, co-pilot, navigator, weapon systems officer, and electronic warfare officer, it is powered by 8 Pratt & Whitney TF-33 turbofan engines, each producing around 17,000 pounds of thrust. With a maximum speed of about 650 miles per hour, a combat range of 8,800 miles, and a service ceiling of 50,000 feet, the B-52 delivers both range and performance on a global scale. Its design emphasized versatility, durability, and adaptability, allowing it to remain relevant across decades of technological change. Over the years, the B-52 has undergone numerous upgrades, including advanced avionics, electronic warfare systems, and modernized weapons capabilities, ensuring it can meet the demands of contemporary combat. Unlike earlier bombers, it has proven effective in a wide array of missions, from nuclear deterrence to conventional bombing campaigns in conflicts like the Vietnam War and the Gulf War. Its remarkable longevity reflects both its innovative design and cost-effectiveness, solidifying the B-52 as a cornerstone of strategic air power. Even after more than 70 years of service, it is projected to remain in operation well into the 2050s, a true symbol of enduring military capability. Finally, the Rockwell B-1 Lancer exemplifies the move towards speed, flexibility, and cutting-edge technology in bomber design. Officially introduced on October 1, 1986, this supersonic aircraft operates with a crew of 4, including the aircraft commander, pilot, offensive systems officer, and defensive systems officer. It is powered by 4 General Electric F101 afterburning turbofan engines producing 17,390 pounds force thrust each in dry mode and up to 30,780 pounds force with afterburner. With a maximum speed of around 830 miles per hour at 50,000 feet, a range of approximately 5,100 nautical miles, or 4,100 with a heavy weapon load, and a service ceiling of 60,000 feet, the B-1 delivers both speed and long-range strike capability. This aircraft features variable sweep wings, enabling it to adjust wing configuration for optimal performance at both high speeds and low-altitude flight. Initially developed as a nuclear bomber, the B-1 was later adapted to carry conventional weapons, allowing it to take on a wide range of modern combat missions. Its development incorporated lessons learned from previous bombers, focusing on survivability, speed, and precision in increasingly complex battle environments. Its large payload capacity, advanced avionics, and precision strike capabilities made it a crucial component of the U.S. Air Force's strategic arsenal. Over the years, the B-1 has played a significant role in numerous operations, demonstrating both versatility and reliability in varied combat scenarios. However, with the advent of newer stealth bombers and evolving military strategies, the B-1 is gradually being phased out, signaling the close of another important chapter in the evolution of long-range strike aircraft. In conclusion, the journey from the B-29 to the B-1 Lancer reflects the rapid advancement of aviation technology over decades. Each aircraft introduced new innovations, whether it was pressurized cabins, aerial refueling, jet propulsion, or supersonic flight. Together, they tell a story of engineering excellence, strategic necessity, and constant adaptation to the changing nature of warfare. If you enjoyed this deep dive into the evolution of strategic bombers, make sure to like the video, subscribe to the channel, and turn on notifications for more amazing aviation content.